All right, today in geometry, we are looking at section 10.5, 10.6, angle relationships and segment lengths in circles. We're going to start out with some theorems. The first one says, if a tangent and a chord or secant intersect at a point of tangency on the circle, then the measure of each arc formed is 1/2 the measure of its intercepted arc. So in this figure, line MJ is a secant and line LK is a tangent line intersecting at the point of tangency, which is point J. Arc MJ is the intersected arc of angle MJL, and arc MYJ is the intercepted arc of angle MJK. Therefore, angle MJL, so angle MJL, this angle right here, is half of this arc. Angle MJK, this angle right here, is half of arc MYI. So let's practice some of those. So the first one, it says line M is tangent to the circle. Find the measure of the red angle or arc. The one that we're looking at is this angle right here. It has the 1 in it. So here the measure of angle 1 is going to be half of this arc. So 1/2 of 130 degrees. So this is going to be 65 degrees. The second one, the arc that we want is KJL. We know this angle, so my arc is going to be double my angle. So 2 times 125 is 250 degrees. The next one over here says find the indicated measure. First, the measure of angle 1. I know its intercepted arc is 210, so I just want half of that. So half of 210 degrees is 105 degrees. The next one, they want the measure of arc RST. RST, that arc is intercepted by this angle, so I just need to double my angle. So 2 times 98 gets us 196 degrees. And our last one, the measure of arc XY, that is intercepted by this angle. So again, I double my angle, so 2 times 80, I get 160 degrees. So this theorem is a lot like the theorem that we looked at yesterday with intersected arcs with inscribed angles. Next, we're going to look at intersecting lines in circles. If 2 lines intersect a circle, there are 3 places where those lines can intersect. First, it can be on the circle. So right here, they can intersect on the circle itself. They can intersect inside the circle, or they can intersect outside the circle here. So we'll look at the angles inside the circle theorem. If 2 chords intersect inside a circle, the sum of the measure of each angle is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. So over here, if I'm looking for angle 1, that would be half of arc AB plus arc DC. If I was looking for angle 2, that would be 1/2 the sum of arc AD and the arc CB. So let's practice some of those. So this first one, we're going to find X. So arc JM is 130, arc KL is 156. So we're just going to say X is equal to 1/2 those 2 arcs added together. So 130 plus 156. So I want to add those 2 together. So when I add those 2 together, I get 286. So now I just want half of 286. So that is 143. So X is 143 degrees. Our next example, this is the angle I want. I know this arc and this arc that are intercepted by that angle. So again, X is equal to 1/2 angle 60, or sorry, arc 63 plus arc 89. So again, I want to add those 2 arcs together. So 63 plus 89 gets us 152. And then I want half of that, so 76 degrees. Let's turn that page over. Now we're going to look at angles outside the circle theorem. If a tangent and a secant, 2 tangents or 2 secants, intersect outside of a circle, then the measure of the angle formed is 1/2 the difference of the measures of the intercepted arcs. So we have 3 different pictures, all the same formula. So here I have a secant. Sorry, the secant is AB, and then this line that has the C on it is my tangent. So this angle 1 out here would equal 1/2 arc BC minus arc AC. We always put the bigger arc first. This next one, I have two tangents. So this angle 2 is equal to 1/2 this great big arc minus this little arc here. And finally, I have two secants. So this angle 3 out here is equal to 1/2 arc XY minus arc WZ. So let's try some of those. So to solve for the missing angle, again, 3 different pictures, all the same formula. So I'm looking for this angle right here. I'm just going to call that X. So I'm going to say X is equal to 1/2. This great big arc out here is 145 minus the little arc inside, 55. So here I want to subtract those. So 145 minus 55 is 90. Next half of 90, 45 degrees. This time we're looking for an arc. So I'm going to put my X there. I know the angle out here is 58. So I would say 58 is equal to 1/2 my great big angle, or sorry, my great big arc, which I'm looking for, X, minus my little arc, 89. I could distribute my 1/2, but most people like to get rid of that fraction. It's 1/2, which is the same thing as dividing by 2. So the opposite of dividing by 2 is multiplying by 2. I just have to remember to multiply everything. So I have to multiply this side as well. So 2 times 58 gets me 116 on this side. Here my 1/2 and my 2 cancel, and I'm just left with X minus 89. So now to get X by itself, all I have to do is add 89 to both sides. So I get X is equal to 205 degrees. And our last picture, we want this little bitty arc in here. This is my X. I'm going to have to call this great big one because I don't know it, but I know all together is 360 because it's the whole circle. So I can call this great big one 360 minus X. So then I would set this up 50 equals 1/2 my big arc, 360 minus X, minus my little arc, X. Again, I'm going to get rid of the 1/2 by multiplying everything by 2. So 2 times 50 gets me 100. My 1/2 and my 2 cancel, and I'm just left with 360 minus negative X and negative X give me minus 2X. So I'm going to subtract 360 from both sides, and I get negative 260 equals negative 2X. This time I'm dividing by negative 2. And so I get X is equal to 130 degrees. The next one, it tells me when two chords intersect in the interior of a circle, each chord is divided into 2 segments that are called segments of the chord. So we have a segments of the chord theorem, which tells me if 2 chords intersect in the interior of a circle, the product of the lengths of the segment of one chord is equal to the product of the lengths of the segments of the other chord. So in this picture, I have my 2 chords. So the first chord, I get AE, and I multiply it by EB. That's going to equal the second chord, EC, times DE. So let's try one of those examples. Here we want to find the measures of ML and JK. So first to do that, I have to find out what X is. So my first chord, I have X and X plus 4. So those get multiplied together. X times X plus 4 equals the other chord, I have X plus 2 and X plus 1. So I multiply X plus 2 and X plus 1 together. So now I'm ready to distribute. So this side I get X squared plus 4X. Over here, multiplying 2 binomials, so I FOIL. So X times X gets me X squared. X times 1 gets me X. 2 times X, 2X. And 2 times 1, 2. I can see that when I move this X squared over, my X squareds cancel. So now I have 4X equals, I'm going to combine like terms here and get 3X plus 2. Subtract 3X, so I get X is equal to 2. But they asked me to find ML and JK. So ML, so I have to plug 2 in. So ML is this one here. So if I plug 2 in here, 2 plus 2 is 4. Plug 2 into the bottom one, 2 plus 1 is 3. So 4 plus 3, 7 units is ML. Now JK, again, plugging it in. So this one was just X, 2. Over here, 2 plus 4 is 6. So 6 plus 2 is 8 units. So always make sure that you are reading the directions and plugging back in when you need to. So now we're going to look at tangents and secants. So this tells me that a secant segment is a segment that contains a quarter of the circle and has exactly one endpoint outside the circle. So in this picture, that is this right here is my secant. The part of a secant that is outside is called the external secant segment. So this is my external secant segment. And then in this picture, I also have a tangent. So let's go to the next page and look at the theorem on those. So first we have a segments of secants theorem. If two secant segments share the same endpoint outside a circle, then the product of the lengths of one secant segment and its external segment equals the product of the lengths of the other secant segment and its external segment. So here, AE and EC are my externals. So on the first secant, I would take EA, multiply it by the entire secant, EB. Set that equal to the outside part, EC, times the entire secant, ED. So we're going to try one of those. It doesn't matter which one I start with, so I'm going to start with the 3 on the outside. So 3 gets multiplied by the whole thing. I have to add those, x plus 3. I set that equal to the outside one, 4, times the whole thing. 4 plus 2 gets me 6. I need to distribute, so I get 3x plus 9 equals 24. I'm solving for x, so I'm going to subtract 9 from both sides. So then I get 3x equals 15. Finally divide by 3, x is equal to 5. One last theorem, the segments of the secants and tangents. If a secant and a tangent share an endpoint outside a circle, the product of the lengths of the secant segment and its external segment equal the square of the length of the tangent segment. So here EA is my tangent, so I square that, EA squared. I set that equal to the external part, EC, times the entire length. So let's try that one. I want to start with the tangent segment. That's 15. I square that one. So 15 squared equals the other one outside, x, times the entire inside, x plus 14. So over here, 15 squared gets me 225. X times x, x squared, plus 14x. This time, my x squared is not going to go away, so that means I want everything on the same side. So when I move my 225 over, I look at something that I'm either going to have to factor or do the quadratic formula on. I always check to factor first. Remember, to factor, I'm looking for 2 numbers that I could multiply together to get negative 225, but add to get 14. Unfortunately, in this case, this does not factor, so we have to do the quadratic formula. So remember, that's negative b plus or minus the square root, b squared minus 4ac, everything divided by 2a. So I'm going to set that up. X equals negative b, so negative 14, plus or minus the square root, 14 squared, minus 4 times my a is 1, my c is negative 225. Everything divided by 2 times my a, which is 1. So now I'm going to start simplifying. So I have negative 14 plus or minus underneath my radical. When I work out 14 squared and then negative 4 times negative 225, that's going to turn to positive, and I add all of that together. We get 1096 underneath the radical, everything divided by 2. So now I want to take the square root of 1096. So I get x equals negative 14 plus or minus. That's about 33.1, everything divided by 2. So remember here I have 2 problems. So the first one, negative 14 plus 33.1 divided by 2, and negative 14 minus 33.1, everything divided by 2. When I work out this first one, I get x is equal to 9.55. When I work out the second one, I get x equals negative 23.55. Now I have to remember, what is x representing? X represents a length. I cannot have a negative length, so I can get rid of that one, and I know my answer is the 9.55. So we've seen an example of each of these. So now we're going to see all of our examples mixed up. Just like all of our previous days, again, if you look at the picture, match the picture with the example, the theorem, then you know exactly which theorem you're using. So this first one, I have 2 chords inside. So I take one chord, I multiply their products together. So here I would have 9 times 16. I set that equal to the products of the other one. So 18 times x. So 9 times 16 gets me 144 equals 18x. All I have to do is divide by 18. So 144 divided by 18, x is equal to 9. We'll go below that one. I have 2 secants. I take the external one, so 18, times, I add the whole thing together, so 18 plus 22 is 40. I set that equal to the outside one, x, times the whole thing added together, x plus 29. So on this side, 18 times 40 is 720, equals x squared plus 29x. Again, my x squared won't go away, so I want everything on the same side. X squared plus 29x minus 720 equals 0. Again, I'm looking at factor or quadratic formula. So first I'm going to see, can I factor? I'm looking for 2 numbers I can multiply together to get negative 720, but add to get positive 29. This one factors. If I take positive 45 and negative 16, when I multiply those, I get negative 720, but when I add them, I get positive 29. So my first parenthesis, x plus 45. My second parenthesis, x minus 16. And remember, I just set both of these equal to 0 and I solve. So this one is going to get me x equals negative 45. This one is going to get me x equals positive 16. Again, my x is representing a length, no negative. So the positive 16 is my answer. We'll go over here to the one marked number 3. Again, I have a secant and another secant. So I set it up the exact same way. So the external part, 3, times the whole thing added together. So x plus 3 and 2, 5, equals the external part, x plus 1, times all of it added together. So x and x gets me 2x. 1 plus negative 1, nothing. So now I want to distribute. So I get 3x plus 15 equals 2x squared plus 2x. Again, my x squared is not going to go away, so I'm going to get everything on the same side. So then I get 2x squared minus x minus 15 equals 0. Again, I'm going to check, can I factor? I'm looking for 2 numbers I can multiply together to get negative 15, but add to get negative 1. That's going to be a negative, sorry, not a negative 15. 2, because this is a 2 out here, I have to multiply the 2. So I'm looking for a negative 30. 2 numbers I can add, multiply together to get negative 30, but add to get negative 1. So let's see, negative 30, we could do a negative 6 and a positive 5. Negative 6 times 5 gets me negative 30. When I add them, I get a negative 1. So I'm just going to rewrite this negative x as a negative 6x and a positive 5x. So I'm going to rewrite this 2x squared minus 6x plus 5x minus 15 equals 0. Remember, this is factor by grouping, so I'm going to group those 2 together and these 2 together. So the first 2 I grouped together, I'm looking for what do they have in common. They both have a 2x, so I can take out a 2x. When I do that, I'm left with an x minus 3. 5x minus 15, I can take out a positive 5, and I'm left with x minus 3. Whenever we factor by grouping, we should have the same thing in both sets of parentheses. We do, so I know we've done it right. So this is 2x plus 5 and x minus 3 equals 0. I combined what I took out of both of them, the 2x plus 5. So now I set both of these equal to 0. So here I would get 2x equals 5, right, negative 5, x equals negative 5 halves. Here when I solve, I just get x equals 3. Again, I cannot have a negative because I'm looking at a length, so that goes away, and my answer is the positive 3. All right, 2 more examples. So this next one, I have this angle is 102. I'm looking for this arc, and I know this arc. I don't know the intercepted arcs from the angle that I have, but I can find this angle. So I'm going to call that x right now, because I know that x and 102 are a linear pair. So together they have to equal 180. So 180 minus 102 equals x. So now I know that x is equal to 78. So now I can set this up. 78 is equal to 1/2. I add my 2 arcs together, y plus 95. Again, if I want to get rid of the 1/2, I'm going to multiply everything by 2. So 78 times 2 gets me 156. The 1/2 and the 2 cancel, and I'm just left with y plus 95. Subtract 95, and I get y equals 61. All right, our last example. I know this angle in here is 30. I'm looking for this arc. So my formula says the angle 30 equals 1/2. This time I subtract my 2 arcs. The bigger one, A, minus the one on the inside, 44. Again, if I want to get rid of that 1/2, I'm going to multiply everything by 2. So 2 times 30 gets me 60. The 2 and the 1/2 cancel. A minus 44. Add 44 to both sides, and I find out that A is 104 degrees. So that wraps up section 10.5, 10.6, and that is the end of chapter 10.